Is my AI hallucinating or telling the truth? If you've ever asked this question, you're not alone. Most professionals lack the fundamental skills to evaluate AI outputs critically. Today, I'm breaking down how to develop true data literacy that transforms you from an AI consumer to an AI evaluator, a skill that will make you invaluable as 87% of organizations struggle with failed data initiatives. Have you ever wondered if your understanding of AI has been shaped more by Hollywood than Harvard? Think about it. When someone mentions artificial intelligence, what images come to mind? Is it HAL 9000's calm, all-knowing voice from 2001, A Space Odyssey? Or perhaps Tony Stark's helpful digital assistant Jarvis from the Iron Man franchise, always ready with the perfect answer to any question? This phenomenon has a name: the Oracle Fallacy. It's the widespread misconception that AI systems function as all-knowing entities, capable of providing perfect answers to any question we might pose. The origin of this fallacy isn't found in computer science textbooks or AI research papers. It's rooted in decades of science fiction that has fundamentally shaped our collective understanding of what AI can and should do. In films, AI characters are rarely shown struggling with incomplete data or producing uncertain results. Instead, they deliver confident, authoritative responses regardless of the complexity of the question. They don't hesitate, they don't qualify their answers with probabilities, and they certainly don't admit when they simply don't know something. These cinematic portrayals create a dangerous expectation gap when we transition from movie theaters to meeting rooms. A recent survey revealed something striking. Many professionals in decision-making positions base their expectations of what AI should be able to accomplish directly on what they've seen in popular media. This isn't just an interesting cultural observation, it has serious implications for businesses implementing AI solutions. When executives and managers expect AI systems to function like movie AIs, they're setting themselves up for disappointment and potential project failure. Real AI systems don't possess general intelligence or intuition. They can't spontaneously research topics beyond their training data or generate insights about domains they've never encountered. The reality is far more nuanced and limited. Today's AI systems, even the most sophisticated ones, are fundamentally pattern-matching tools that require carefully structured, high-quality data to function effectively. They don't know anything in the human sense. They identify statistical patterns in the information they've been trained on. And when that information is incomplete, biased, or irrelevant to the question at hand, the AI's output suffers accordingly. This gap between expectation and reality creates a dangerous situation in business settings. Organizations invest millions in AI initiatives expecting Oracle-like wisdom, only to find themselves with tools that require significant human oversight, data preparation, and critical evaluation of results. The disconnect isn't just disappointing. It can lead to abandoned projects, wasted resources, and missed opportunities for more realistic applications of the technology. Consider the Simpson's paradox, a statistical phenomenon where a trend appears in separate groups of data but disappears or reverses when the groups are combined. A movie AI would simply provide the correct interpretation, but real AI systems might completely miss this nuance unless specifically designed to check for it. Human judgment and statistical expertise remain essential when interpreting AI outputs, something rarely acknowledged in fictional portrayals. The consequences extend beyond mere disappointment. Organizations making critical business decisions based on misunderstood AI capabilities can find themselves in serious trouble. The expectation that AI can autonomously analyze situations and make decisions without human guidance has led to an astonishing statistic. Approximately 87% of data science projects never reach implementation. The primary reason? Not technical limitations, but misalignment of expectations and poor communication between technical teams and business stakeholders. The gap between fiction and reality isn't just about technical capabilities, it's about fundamental misunderstandings of how AI interacts with data quality, human oversight, and the need for critical thinking. In movies, the AI's knowledge seems to exist independent of data quality concerns. In reality, the accuracy and reliability of AI systems are directly dependent on the data they're trained on. Garbage in, garbage out, as the saying goes. That garbage in, garbage out reality has serious consequences. Behind the impressive demos and glossy presentations lies a sobering truth. 87% of data science projects never make it to implementation. Let that sink in. Would you invest significant resources in an initiative with odds of success worse than a coin flip? Yet that's precisely what's happening across industries as organizations continue pouring millions into data science projects, despite overwhelming evidence that most will never deliver on their promises. This isn't a technology problem, it's a human one. The disconnect between technical teams and business stakeholders creates a fundamental misalignment that dooms projects from the start. Data scientists build sophisticated models while business leaders expect different outcomes, with neither side fully understanding the other's perspective. Consider what happens in these failed projects. A business leader approaches a data team with a problem statement that sounds clear but contains unstated assumptions and imprecise language. The technical team interprets this through their specialized lens, building what they believe matches the requirements. Months later, when they proudly present their solution, the business stakeholders respond with confusion or disappointment. That's not what we asked for. The root of this disconnect lies in literacy gaps that create misaligned expectations. Business stakeholders often lack the technical understanding to articulate their needs in terms that data scientists can implement directly. Meanwhile, technical teams frequently fail to translate complex statistical concepts into business value that resonates with decision makers. In one manufacturing company, executives invested heavily in a predictive maintenance system that their data science team spent 6 months developing. When the system was finally ready, operations managers couldn't interpret the outputs or integrate them into their workflows. The project was shelved despite its technical excellence because the team built a solution that was mathematically sound but practically unusable. A financial services firm experienced similar issues when their risk assessment AI produced recommendations that contradicted established practices. Rather than examining why the AI reached different conclusions, executives simply rejected the system entirely, assuming it was flawed. In reality, the AI had identified genuine inefficiencies in existing processes, but without a common language to discuss these findings, this potential breakthrough became another failed project statistic. These communication barriers don't just derail individual projects, they create organizational scar tissue that makes future initiatives harder to launch. After experiencing a failed data project, stakeholders become reluctant to invest again, viewing data science as overpromising and underdelivering. The lack of a shared vocabulary compounds these issues. When a data scientist talks about model confidence intervals, business users may hear how certain the AI is about its answer. Similar phrases with critically different meanings. Similarly, when stakeholders ask for accurate predictions, they might mean recommendations I can trust, while the data team interprets this as a request for specific statistical performance metrics. What makes this situation particularly troubling is how the cycle perpetuates itself. Instead of addressing the fundamental literacy gap, organizations often respond to failed projects by investing in more technical solutions or hiring additional specialists. This approach treats the symptom rather than the cause, leading to the same disappointing outcomes with increasingly expensive tools. The organizations that break this cycle recognize that teaching stakeholders about data literacy is just as important as building technical solutions. When business users understand how to effectively use data solutions, not necessarily how to build them, projects begin to succeed. This educational component is rarely included in project plans, yet it's often the determining factor between success and failure. Education may be crucial for data project success, but how exactly do you transform an organization filled with varying technical abilities into one with shared data literacy? While companies recognize this need, most lack a systematic approach to building these skills. The solution might have been hiding in plain sight all along in the field of education. Enter the ADDIE Model, a proven educational framework that has transformed learning outcomes across industries for decades, yet remains virtually unknown in most data teams. This structured approach to instructional design offers a blueprint for addressing the AI literacy gap that plagues so many organizations. ADDIE isn't just another corporate acronym, it's a systematic process consisting of 5 interconnected phases: analysis, design, development, implementation, and evaluation. When applied to data literacy initiatives, this framework transforms vague training goals into concrete, measurable outcomes. The analysis phase begins with an honest assessment of your organization's current data literacy landscape. Rather than making assumptions about what people know, this phase involves identifying specific knowledge gaps across departments. It answers critical questions. Can marketing professionals interpret model confidence scores? Do operations managers understand the limitations of predictive algorithms? This diagnostic approach prevents the common mistake of creating one-size-fits-all training that's either too basic or too advanced. Moving into the design phase, organizations can create targeted learning paths that address the specific needs of different stakeholder groups. Finance teams might need deeper training in statistical concepts, while product managers may benefit more from understanding how algorithms shape user experiences. This tailored approach ensures that everyone receives relevant education rather than generic AI awareness. The development phase is where the actual educational materials take shape. Here, the focus shifts to creating resources that resonate with both technical and non-technical staff. Rather than drowning business stakeholders in technical jargon or oversimplifying concepts for technical teams, effective development creates materials that speak to each audience in their language while building toward shared understanding. Implementation brings these carefully crafted programs to life across the organization. Unlike traditional training rollouts that often prioritize convenience over effectiveness, ADDIE implementation strategies focus on creating environments where learning sticks. This might involve spacing learning over time rather than condensing it into intensive boot camps, or incorporating hands-on projects that apply concepts to real business challenges. The evaluation phase closes the loop by measuring outcomes against the objectives identified during analysis. Instead of simply tracking attendance or satisfaction scores, robust evaluation examines whether the literacy gaps identified initially have actually closed. Are stakeholders asking more sophisticated questions about AI outputs? Has cross-functional collaboration improved? These indicators reveal whether the program is truly transforming organizational understanding. The power of the ADDIE model lies in its systematic approach to a problem that most organizations treat haphazardly. Rather than hoping that occasional lunch and learns or technical documentation will somehow create data literacy, ADDIE provides a structured pathway to transformation. Organizations that implement this framework discover that improving data literacy isn't about making everyone into a data scientist. It's about creating a shared language and mental models that allow for meaningful collaboration. The systematic nature of ADDIE addresses another crucial challenge: scalability. As organizations grow and evolve, ad hoc approaches to education quickly break down. New hires miss crucial context, departments develop inconsistent practices, and the knowledge gap between teams widens. ADDIE creates a repeatable, improvable process that grows with the organization, ensuring that data literacy becomes embedded in the organizational culture rather than remaining siloed in technical teams. Embedded data literacy transforms organizational culture, but this transformation hinges on a critical misconception about what data literacy actually entails. While most training programs focus heavily on technical skills and tools, the professionals who navigate AI most effectively rely primarily on a different set of abilities altogether, abilities that challenge our fundamental assumptions about human-AI interaction. When organizations invest in data literacy, they often prioritize coding classes, SQL workshops, and technical training. The implicit assumption is that to work effectively with AI and data systems, one must first master the technical foundation. But what if this approach is backward? Research consistently shows that critical thinking abilities far outweigh technical knowledge when it comes to effective interaction with AI systems. This isn't to say technical skills aren't valuable. They certainly are. But they're secondary to a more fundamental set of capabilities that truly define data literacy in practice. The difference between an AI-savvy professional and one who merely follows the machine's lead comes down to 4 distinct capabilities. First is critical assessment, the ability to question what AI systems tell us. Unlike passive consumption of information, critical assessment involves actively evaluating AI outputs against business objectives and common sense. When an AI recommends a course of action, data-literate professionals don't simply implement it. They ask, does this make sense given what we know about our business? What assumptions might be embedded in this recommendation? What factors might the system be overlooking? This questioning stance prevents the blind acceptance of AI as an infallible oracle. The second component is context awareness. Data-literate professionals understand that AI tools are designed for specific purposes and contexts. They recognize when AI applications are appropriate and, crucially, when they aren't. Context awareness prevents the misapplication of powerful tools to inappropriate situations. Consider a marketing team that uses a customer segmentation algorithm designed for retail applications to healthcare patients. Without context awareness, they might miss critical differences between these domains that make the algorithm's recommendations potentially harmful. Third is bias recognition. AI systems learn from historical data, which means they can inherit and amplify existing biases. Data-literate professionals develop a keen eye for spotting these patterns. They question not just what the data shows, but what might be missing from it. By identifying potential biases in data collection, measurement approaches, or algorithmic design, they prevent the perpetuation of harmful patterns that could disadvantage certain groups or lead to flawed business decisions. The fourth component might be surprising: communication skills. Data literacy isn't just about understanding data yourself, it's about effectively translating complex insights for others. The most technically proficient data scientists who cannot explain their findings to stakeholders might as well not have discovered them at all. Communication skills bridge the gap between technical and business understanding, ensuring that data insights actually influence decisions rather than remaining trapped in technical documentation. These 4 components, critical assessment, context awareness, bias recognition, and communication, form the core of true data literacy. Together, they enable professionals to engage with AI systems as informed partners rather than passive users. They transform the relationship from one of blind trust to one of thoughtful collaboration. Organizations that recognize these components and build literacy programs around them see significantly different outcomes than those focusing exclusively on technical training. Their teams ask better questions, design more effective solutions, identify potential problems earlier, and collaborate more effectively across departments. The investment in these core literacy components pays dividends far beyond what technical training alone can achieve. The relentless pursuit of perfect data might be the invisible obstacle crippling your AI initiatives. While we've established the importance of critical thinking skills in data literacy, there's a costly misconception lurking beneath the surface of many organizational data strategies. Companies investing millions in achieving flawless data sets often find themselves paralyzed, unable to move forward with AI implementation while their competitors race ahead with good enough data approaches. This perfectionism trap manifests when teams postpone AI projects indefinitely because the data isn't ready yet. You've likely heard this phrase in planning meetings, or perhaps you've said it yourself. But what if this seemingly responsible stance is actually sabotaging your organization's progress? The core issue stems from misunderstanding what good data actually means in practice. Rather than pursuing an abstract ideal of perfection, forward-thinking organizations focus on what experts call fit-for-purpose data, information that adequately serves the specific needs of a business question. This pragmatic approach recognizes that different business questions naturally require different quality standards. Consider a manufacturing company that delayed implementing a predictive maintenance system for 3 years while trying to clean decades of inconsistent equipment data. Meanwhile, their competitor launched a similar system using only 2 years of standardized maintenance logs, gaining valuable insights while accepting certain limitations. The first company pursued perfection and got nothing. The second embraced good enough and gained competitive advantage. This contrast reveals a fundamental principle. Context determines necessary quality. A basic inventory analysis might function perfectly with modest data standards, while a healthcare diagnostic algorithm demands far more rigorous validation. The key is matching quality requirements to actual business needs rather than applying a one-size-fits-all standard of perfection. The concept of minimum viable data quality offers a practical framework for this approach. Similar to the minimum viable product philosophy in software development, it focuses on identifying the least amount of data quality necessary to achieve your objectives. This prevents overinvestment in areas that won't meaningfully impact outcomes. When organizations shift from perfectionism to pragmatism, profound changes occur in how they prioritize data quality investments. Instead of spreading resources thinly across all datasets, they strategically allocate efforts where quality truly matters for specific business applications. This targeted approach maximizes return on data quality investments. One expert captured this philosophy perfectly. The perfect data is the one that my client people understand. This insight emphasizes that usability and comprehension often matter more than technical perfection. A slightly imperfect dataset that stakeholders can effectively interpret will generate far more value than a pristine collection that nobody can navigate or apply. Organizations implementing fit-for-purpose standards typically establish tiered quality frameworks. These frameworks define different levels of required quality based on use cases, from exploratory analysis to customer-facing applications. This allows teams to move forward with AI initiatives without unnecessary delays while still maintaining appropriate quality standards where they matter most. The shift from perfectionism to pragmatism also transforms how teams communicate about data. Rather than making absolute statements about data being good or bad, they discuss fitness for specific purposes. This nuanced language helps stakeholders understand that quality exists on a spectrum relevant to particular applications. Traditional thinking suggests that imperfect data yields imperfect insights. However, organizations embracing fit-for-purpose approaches discover something surprising. Imperfect data combined with strong critical assessment often produces more valuable business outcomes than perfect data analyzed without context. The human element of interpretation remains essential. The tension between perfection and pragmatism becomes particularly evident in organizations transitioning to more advanced AI applications. Teams accustomed to report-oriented data work often maintain unnecessarily rigid standards when moving into predictive analytics, not recognizing that different applications have fundamentally different quality requirements. Your AI system might be silently reinforcing harmful biases despite passing all technical evaluations and quality checks. This paradox, where technically sound models produce socially problematic outcomes, represents the next frontier of AI literacy that separates truly responsible implementations from potentially harmful ones. What makes AI bias particularly troubling isn't just its existence, but its invisibility. Even teams with the best intentions and technical expertise frequently miss biases embedded in their systems. These biases typically don't announce themselves during development or testing phases. Instead, they operate quietly in the background, influencing decisions in ways that may remain undetected until real harm has occurred. After loan applications have been unfairly rejected, medical treatments inappropriately prescribed, or hiring decisions subtly skewed. Understanding the taxonomy of AI bias provides a framework for detection. 4 distinct categories emerge when examining how bias infiltrates AI systems. Selection bias occurs during the initial data collection and sampling processes. Consider a healthcare AI trained predominantly on data from urban teaching hospitals. This system will likely perform poorly when deployed in rural settings with different patient demographics and disease patterns. The sampling methods themselves create a disconnect between the model's training environment and its intended application context. Measurement bias stems from how we choose to quantify the phenomena we're studying. When organizations define success metrics that inadvertently favor certain groups or outcomes, this bias gets encoded into the AI's understanding of what good looks like. For instance, if a creditworthiness algorithm heavily weighs factors that correlate with socioeconomic status rather than actual repayment behavior, it will systematically disadvantage applicants from lower income backgrounds regardless of their true creditworthiness. Perhaps most insidious is algorithmic bias, where seemingly neutral technical choices amplify existing patterns in ways that create discriminatory outcomes. Machine learning systems excel at finding patterns, but they make no moral distinctions between helpful correlations and harmful stereotypes. Without careful oversight, these systems efficiently optimize for the patterns they discover, potentially reinforcing societal inequities that exist in the training data. Interpretation bias occurs at the human-AI interface, where outputs are translated into decisions. Even with a technically sound model, the ways stakeholders interpret and apply AI recommendations can introduce bias. Decision makers may selectively accept AI recommendations that confirm their existing beliefs while scrutinizing those that challenge their intuitions, creating an inconsistent application of the AI's insights. Detecting these biases requires systematic approaches that go beyond casual observation. Cross-validation techniques help identify whether a model performs consistently across different demographic groups or contexts. By testing model performance on various subpopulations within your data, you can uncover disparities that might otherwise remain hidden. Sensitivity analysis provides another powerful lens, allowing you to measure how changes in specific variables affect outcomes. By methodically varying inputs while holding others constant, you can determine which factors most significantly influence your model's decisions and whether these influences align with your intended design. The detection of bias also demands a deep understanding of the context in which data was created. Every dataset reflects the social, historical, and organizational circumstances of its creation. Questions about who collected the data, why it was collected, what was measured, and what was omitted provide critical context for identifying potential blind spots. Critical approaches to analyzing outputs represent another essential practice. Rather than accepting AI recommendations at face value, teams should develop the habit of questioning results, especially when they align too perfectly with expectations or historical patterns. Often the most valuable insights come from investigating why an AI system produced a particular output rather than simply implementing its recommendations. The technical vocabulary that makes perfect sense to data scientists often sounds like an alien language to the business leaders who must ultimately implement AI recommendations. This translation challenge represents the invisible barrier that silently kills more AI initiatives than any technical limitation, and mastering it might be the most undervalued skill in the entire data science toolkit. Imagine you've developed a sophisticated anomaly detection algorithm that identifies potential fraud with remarkable accuracy. You're excited to present it to the financial team, but when you mention unsupervised learning with isolation forests and dimensionality reduction techniques, you notice their eyes glazing over. This isn't a failure of your audience's intelligence, it's a breakdown in translation. Technical and business professionals essentially speak different languages, each with their own specialized vocabulary, developed to efficiently communicate within their domains. When these worlds collide, the results can be disastrous. Technical teams become frustrated that business stakeholders don't get it, while business leaders feel that technical teams are deliberately obscuring simple concepts behind impenetrable jargon. Effective translation requires starting from where your audience is, not where you are. This means understanding their current knowledge level and ensuring that your explanation relates to concepts they already grasp. Before launching into technical explanations, successful translators take time to understand their audience's priorities, concerns, and existing mental models of how systems work. One powerful technique is the strategic use of business-relevant analogies. Rather than explaining how a random forest algorithm works mathematically, you might compare it to having multiple diverse teams evaluate the same business problem independently, then coming together to vote on the best solution. This connects the unfamiliar technical concept to familiar business practices of collaborative decision-making. Visual aids serve as another crucial bridge across the technical divide. As one expert noted, using visual aids such as graphs and diagrams can significantly enhance understanding as they allow stakeholders to visualize complex relationships and concepts, making them more accessible. Techniques like mind maps can transform abstract statistical concepts into intuitive visual relationships that non-technical stakeholders can grasp immediately. The most effective translators don't simply present prepackaged explanations, they actively involve stakeholders in the process. Co-creation sessions, where technical and business teams work together to develop solutions, build shared understanding organically. When stakeholders participate in creating visual representations of data and processes, they gain a sense of ownership and develop deeper comprehension than they would from passive presentations. Descriptive strategies help break down complex concepts into simpler components. Rather than explaining a machine learning algorithm in full technical detail, start by focusing on what it accomplishes in practical business terms, then gradually introduce the technical elements as building blocks toward that outcome. This scaffolded approach allows non-technical stakeholders to build understanding progressively. Trust plays a central role in bridging technical divides. As noted in research, building trust with stakeholders through initial simple deliveries can pave the way for more complex discussions and solutions. When technical teams first demonstrate value with straightforward solutions that clearly address business needs, they establish credibility that makes stakeholders more receptive to more sophisticated approaches later. The best technical translators recognize that persuasion is part of their role. Sometimes, helping stakeholders understand technical concepts requires shifting their perspective to see the underlying challenges differently. This involves amplifying their understanding of the problem before connecting it to technical solutions, helping them recognize why certain approaches are necessary rather than just explaining how they work. Beyond translation lies a radical idea challenging everything we think about technical communication. Organizations making the most progress with AI aren't the ones with the most polished presentations or clearest explanations. They're the ones creating spaces where stakeholders can interact with imperfect, evolving solutions. Let me introduce you to the sandbox approach. Unlike traditional environments where solutions are expected to be flawless before presentation, a sandbox is a controlled space where stakeholders can safely experiment with data solutions that are intentionally unfinished. Think of it as a playground for ideas where the emphasis isn't on perfect execution, but on learning through interaction. This approach fundamentally contradicts conventional wisdom in technical implementation. Traditional methodologies prioritize extensive upfront planning and technical perfection before any stakeholder exposure. The underlying assumption is that business leaders need to see polished, complete solutions to understand their value. But what if this assumption is backward? When we create sandbox environments, something remarkable happens. Instead of stakeholders passively receiving information about a finished product, they become active participants in its evolution. This shift from audience to collaborator transforms how they engage with technical concepts. Consider what happens in a traditional approach. Technical teams spend months developing a solution based on documented requirements, only to discover upon delivery that critical unstated needs were missed. The sandbox approach short-circuits this problem by revealing these hidden requirements early. When stakeholders interact with even simple prototypes, they naturally express needs they didn't articulate in formal documentation sessions. One manufacturing company I worked with struggled for years to implement an inventory optimization system. Multiple technical presentations and detailed explanations failed to gain traction with operations leaders. The breakthrough came when they set up a simple dashboard with real-time inventory data and invited stakeholders to play with different scenarios. Within hours, operations managers were pointing out edge cases and workflow considerations that 6 months of requirements gathering had missed. This experiential learning proves remarkably effective because it engages multiple cognitive pathways. Rather than just hearing about a concept, stakeholders see it in action, manipulate variables themselves, and observe immediate results. The imperfection of sandbox solutions actually becomes their greatest strength. It invites participation rather than passive acceptance. The iterative nature of sandbox development also builds trust between technical and business teams in ways that formal presentations cannot. When stakeholders witness solutions evolving based on their feedback, it creates a powerful reinforcement loop. They see their input directly shaping the technology, which increases their investment in its success and builds confidence in the technical team's responsiveness. A financial services firm struggling with adoption of their risk assessment tools completely transformed stakeholder engagement by implementing weekly sandbox sessions. Instead of quarterly presentations of finished features, they began showing works in progress every Friday. Stakeholders could test partial implementations, suggest modifications, and see their ideas incorporated in subsequent iterations. This approach not only improved the final product, but dramatically increased stakeholder ownership of the solution. This approach aligns naturally with agile methodologies, which emphasize iterative development and stakeholder collaboration. Rather than treating business leaders as customers who receive a finished product, the sandbox approach treats them as development partners whose ongoing input shapes the solution's evolution. The psychological impact of this shift cannot be overstated. When technical teams present perfect solutions, they inadvertently create a dynamic where stakeholders feel they must either accept or reject what's offered. But when teams present works in progress in sandbox environments, they create a collaborative dynamic where stakeholders help shape what's being built. When collaborating with AI systems, there's a moment that separates true professionals from the rest, that crucial juncture when an AI delivers its recommendation. Do you accept it without question, reject it outright, or evaluate it systematically? This evaluation challenge represents the next frontier in AI literacy, one that doesn't require technical expertise but rather a structured approach to critical assessment. Blind trust in AI outputs can lead organizations down treacherous paths, resulting in flawed decisions based on misunderstood recommendations. Yet, excessive skepticism isn't the answer either, as it prevents organizations from leveraging valuable insights that could drive innovation and efficiency. Finding the middle ground requires a practical framework that anyone can apply, regardless of technical background. This is where the 4 C's of AI evaluation come into play: context, confidence, consistency, and consequences. This framework provides non-technical users with a structured approach to assess AI recommendations with appropriate caution and receptiveness. Contextual awareness serves as your first line of defense when evaluating AI outputs. Is the system operating within its intended domain? For instance, a marketing recommendation engine trained on consumer product data might produce plausible sounding but ultimately unreliable suggestions for healthcare decisions. By understanding the AI's design parameters and training environment, you can quickly identify when it's venturing beyond its expertise. This contextual check prevents the misapplication of otherwise valuable tools to inappropriate situations. The second element, confidence assessment, examines how certain the AI system is about its own outputs. Many modern AI systems provide confidence scores or probability distributions alongside their recommendations. These measures reveal the system's internal uncertainty, offering vital clues about reliability. Lower confidence scores warrant closer scrutiny, while higher confidence might justify greater trust, though never blind acceptance. The challenge lies in interpreting these measures in business-relevant terms rather than statistical abstractions. Consistency checks form the third pillar of evaluation. By examining multiple outputs across similar inputs, patterns of reliability or inconsistency emerge. If an AI system produces significantly different recommendations when small, inconsequential details change, it signals potential instability in the underlying model. These consistency tests don't require technical expertise. Simply comparing results across slightly modified scenarios can reveal telling patterns about reliability. The final component, consequence analysis, helps prioritize your verification efforts based on potential impact. Not all AI recommendations carry equal weight. Some might influence minor operational decisions, while others could affect critical business strategies or even human safety. By assessing the potential consequences of accepting an AI recommendation at face value, you can determine when additional scrutiny is warranted. Higher stakes decisions demand more rigorous validation, while lower impact suggestions might require less verification. What makes this framework particularly powerful is its accessibility. You don't need to understand the intricacies of neural networks or machine learning algorithms to apply these principles effectively. The framework translates technical concepts into practical questions that anyone can ask when faced with AI-generated recommendations. Consider how a marketing team might apply this approach when reviewing AI-suggested customer segments. They would first verify the context, ensuring the system was trained on relevant industry data. Next, they'd examine confidence metrics for each segment recommendation. Then they might run consistency checks by slightly modifying customer parameters to see if the AI's recommendations remain stable. Finally, they'd consider consequences. Segmentation affecting small email campaigns might need less scrutiny than those determining major advertising investments. The true power of this critical evaluation approach lies in its balance. It neither dismisses AI capabilities nor accepts them uncritically. Instead, it empowers users to engage thoughtfully with increasingly sophisticated systems, extracting maximum value while minimizing risks. Beyond individual critical evaluation skills lies a transformative opportunity for organizations. Imagine a company where every team member, from executives to frontline staff, understands and engages with data at an appropriate level for their role. This isn't a utopian ideal, but rather the competitive edge that separates truly data-driven organizations from those merely collecting information. The reality in most companies today tells a different story. Despite massive investments in AI and analytics technologies, approximately 79% of organizations face a significant data literacy gap. These companies have built sophisticated data infrastructures but neglected the human element that brings those systems to life. The result? Powerful tools sit underutilized while critical decisions continue to be made based on gut feeling rather than evidence. Building an effective data literacy program requires a systematic approach that begins with understanding your starting point. Before designing any curriculum, successful programs first assess existing literacy levels across different departments. This isn't about administering technical tests to everyone, but rather mapping the current landscape of understanding and identifying specific knowledge gaps relevant to each group's work. Successful data literacy programs emphasize the importance of starting where the stakeholders are, notes one research study highlighting that the most effective initiatives carefully align training with participants' current understanding and needs. This assessment phase might reveal that your marketing team needs stronger skills in interpreting A/B test results, while your operations team struggles to translate predictive maintenance insights into action plans. With a clear literacy map in hand, the next step involves developing targeted curriculum for different stakeholder groups. This is where many programs fail, by creating one-size-fits-all training that either overwhelms non-technical staff or underwhelms those with more advanced needs. Effective curriculum development prioritizes practical applications relevant to each team's daily work. For finance teams, this might mean focusing on financial modeling scenarios, while product teams might benefit from learning how to interpret user behavior analytics. The delivery method matters as much as the content itself. The most successful training methodologies balance theoretical concepts with hands-on practice. Abstract discussions about statistical significance mean little until participants apply those concepts to actual business questions they face, creating opportunities for stakeholders to engage with data directly through guided workshops, interactive dashboards, or collaborative analysis sessions dramatically enhances both retention and application. Measuring the impact of your data literacy program requires looking beyond simple metrics like training attendance or satisfaction scores. The true indicators of success appear in project outcomes and stakeholder confidence. Does your marketing team now independently validate AI-generated customer segment recommendations before implementing them? Can operations managers effectively interpret anomaly detection alerts without calling the data science team? These behavioral changes reflect the program's actual business impact. Another crucial element often overlooked is the co-creation process with stakeholders. Rather than data teams developing solutions in isolation, effective literacy programs encourage collaboration during the development of data products. This approach ensures solutions address actual business needs while simultaneously building deeper understanding of data usage across the organization. Finally, successful data literacy initiatives recognize that needs evolve over time. Regular reevaluation of both the literacy program and resulting data products helps adapt to changing business requirements and ensures training remains relevant. As stakeholders become more sophisticated in their understanding, the curriculum should evolve accordingly, building increasingly advanced capabilities that match their growing expertise. While curriculum evolution matches stakeholders' growing sophistication, there's a neurological shortcut hiding in plain sight that can dramatically accelerate understanding. Your brain is processing this information right now at speeds 60,000 times faster than text processing, an astonishing biological capability that remains largely untapped in most data literacy programs. This remarkable processing differential isn't just an interesting neuroscience fact, it represents perhaps the most powerful tool in our data literacy arsenal. When explaining complex AI concepts, many organizations still default to dense technical documentation, bullet-pointed lists, and text-heavy presentations that fight against our natural cognitive strengths rather than leveraging them. Consider what happens in meetings where stakeholders encounter abstract AI concepts for the first time. When presented with paragraphs of technical text describing a neural network, most participants struggle to build a mental model. Yet show them a dynamic visualization of the same network, processing information, with nodes lighting up as signals pass through layers, and understanding blooms almost instantly. This isn't just preference, it's how our visual processing system has evolved over millennia to rapidly identify patterns and relationships. The contrast between effective and ineffective visualization practices becomes particularly apparent in AI literacy. Ineffective approaches often involve generic stock images of robots, circuit boards, or abstract digital patterns that contribute nothing to actual understanding. These decorative graphics might look impressive in presentations but fail to illuminate the underlying concepts. Effective visualization, by contrast, creates direct visual metaphors for complex processes, showing, for instance, how a recommendation engine compares user data points to find patterns, or illustrating decision boundaries in classification problems. For technical concepts that often seem abstract and intangible, visualization serves as a bridge to intuitive understanding. Take the challenge of explaining how an AI system might exhibit unexpected behavior when deployed in new environments. Rather than describing this verbally, a simple interactive visualization can demonstrate how a model trained on one data distribution responds when confronted with another, making immediately apparent what might take paragraphs to explain. The power of visualization extends beyond static images. Interactive tools that allow stakeholders to manipulate variables and immediately see results create powerful learning experiences that engage multiple cognitive pathways simultaneously. A financial services team might struggle to understand model drift through documentation alone, but an interactive dashboard showing performance degradation over time as data patterns shift makes the concept instantly accessible and memorable. This approach is particularly valuable for non-technical stakeholders who may feel intimidated by mathematical notation or programming concepts. By providing visual interfaces that allow exploration without requiring coding knowledge, organizations can democratize access to complex AI concepts and foster more productive conversations across departmental boundaries. The transformation doesn't stop at individual understanding. When teams share a common visual vocabulary for AI concepts, communication becomes more efficient and precise. A data scientist can reference a familiar visualization pattern during discussions with business stakeholders, instantly establishing a shared mental model that prevents misalignment and accelerates decision-making. Perhaps most powerfully, visualization can reveal insights that remain completely invisible in raw data. Patterns, outliers, and relationships that might be mathematically present but practically undetectable in tabular formats become immediately obvious when properly visualized. This capability transforms how organizations approach data exploration and analysis, enabling intuitive discovery that complements more formal analytical processes. Behind the most data-fluent organizations stands a new breed of chief data officer who has transformed from technical overseer into something far more valuable, a literacy champion who bridges worlds that once seemed impossibly distant. The Chief Data Officer role has undergone a remarkable evolution since its inception. Initially created to manage the growing volumes of organizational data and establish governance frameworks, early CDOs were primarily technical specialists focused on data architecture, security protocols, and compliance requirements. Their mandate was clear: protect the organization's data assets and ensure regulatory adherence. Yet this technically oriented role has proven inadequate for addressing today's complex data challenges. While CDOs excelled at implementing data warehouses and establishing access controls, many organizations discovered that simply having well-organized data didn't translate into meaningful business value. The technical infrastructure was in place, but widespread understanding of how to leverage these assets remained elusive. This disconnect helps explain a startling industry statistic. The average chief data officer remains in their position for just 2 to 3 years before moving on. This revolving door phenomenon signals a profound misalignment between organizational expectations and the traditional CDO mandate. Companies hire technical data leaders expecting transformative business outcomes, only to discover that governance alone cannot drive adoption or deliver value. The most successful CDOs have recognized this fundamental tension and are pioneering a new approach to their role. Rather than functioning solely as technical gatekeepers, they're embracing their position as organizational educators and literacy advocates. This shift acknowledges a crucial reality. The greatest data infrastructure in the world provides little value if stakeholders throughout the organization don't understand how to effectively engage with it. Forward-thinking CDOs now dedicate significant portions of their time to building data literacy across their organizations. They're creating educational initiatives tailored to different stakeholder groups, from executive leadership to frontline employees. These programs go beyond technical training to develop critical thinking about data, contextual awareness, and cross-functional communication skills. The balancing act between governance and education represents a delicate but essential evolution. Technical oversight remains important. Data quality, security, and compliance don't become less critical as literacy improves. However, successful CDOs now view these technical considerations as enablers of literacy rather than ends in themselves. They're asking, how can our governance frameworks make data more accessible and understandable to non-specialists? This expanded mandate requires CDOs to develop evaluation frameworks for an increasingly complex ecosystem of data products. Beyond simply managing databases and dashboards, today's CDO must assess which tools truly enhance organizational understanding versus those that might introduce confusion or misinterpretation. They're becoming curators of the data product landscape, selecting solutions that meet both technical requirements and literacy building potential. Perhaps most significantly, CDOs are evolving from technicians into strategic partners within their organizations. This transformation demands a comprehensive understanding of business context and organizational goals. Rather than focusing exclusively on the how of data management, strategic CDOs are deeply engaged with the why, aligning data initiatives with specific business outcomes that create value. The impact of this evolution extends far beyond the office of the CDO. Organizations with literacy-oriented data leadership are seeing improved stakeholder engagement, more realistic project expectations, and higher implementation success rates. Cross-functional teams communicate more effectively about data, leading to more precise requirements and more valuable solutions. The translation gaps that once plagued data initiatives begin to close as a common language and understanding emerge. The dissolution of translation gaps between technical and business teams reveals an uncomfortable truth about modern data careers. The market increasingly favors professionals who defy conventional specialization, developing instead a distinctive pattern of skills that resembles the letter T, deep in one area, yet unexpectedly broad across adjacent domains. For decades, the path to success in data and AI fields seemed straightforward. Specialize intensely in a single technical discipline. Become the statistics expert. Master machine learning algorithms. Excel at data engineering. This narrow but deep approach produced brilliant specialists capable of solving complex problems within their domain. Yet, as organizations implement increasingly sophisticated AI systems, they're discovering that technical excellence alone rarely translates to business value. Enter the T-shaped professional, someone who combines vertical expertise in a specific technical area with horizontal knowledge spanning multiple disciplines. The vertical bar of the T represents their deep technical mastery, while the horizontal bar reflects their ability to understand, communicate, and collaborate across domains they don't personally specialize in. This hybrid profile fundamentally challenges our traditional notions of career development. What makes T-shaped professionals so valuable in data initiatives? Unlike pure specialists who may struggle to connect their work to broader organizational goals, T-shaped individuals naturally bridge technical and business worlds. They understand enough about marketing to translate a recommendation system's outputs for the marketing team. They grasp financial concepts sufficiently to explain how a forecasting algorithm impacts quarterly projections. They can speak to legal considerations when implementing AI systems without being legal experts themselves. This cross-functional fluency proves particularly crucial when leading multidisciplinary AI projects. Consider the implementation of a customer churn prediction system. A T-shaped leader with deep data science expertise might possess enough understanding of sales processes to identify key friction points, sufficient knowledge of customer service workflows to design actionable interventions, and adequate familiarity with privacy regulations to ensure compliance. Without commanding every specialty involved, they effectively orchestrate collaboration across these domains. Developing T-shaped capabilities requires intentional career planning that balances depth and breadth. For technical specialists looking to expand horizontally, rotational assignments across departments offer valuable perspective. Shadowing stakeholders from other business units during their daily work reveals challenges invisible from technical departments. Volunteering for cross-functional projects creates natural opportunities to develop translation skills between domains. Importantly, this horizontal growth doesn't require mastering each adjacent field, just developing sufficient familiarity to communicate effectively. Organizations can systematically foster T-shaped development through structural and cultural initiatives, cross-training programs that temporarily embed technical staff in business units build mutual understanding that persists after the rotation ends. Mentorship pairing technical specialists with business leaders provides guided exposure to strategic thinking. Workshops facilitated jointly by technical and non-technical leaders can establish common vocabulary and frameworks that enhance future collaboration. Perhaps most critically, organizations must reconsider their incentive structures and advancement pathways. When promotion criteria exclusively reward narrow technical accomplishments, professionals naturally focus on deepening their specialty at the expense of breadth. Progressive companies are incorporating collaboration metrics, stakeholder feedback, and cross-functional project outcomes into their evaluation frameworks, explicitly valuing the horizontal bar of the T. The multidisciplinary approach embodied by T-shaped professionals consistently delivers superior AI implementation outcomes. Projects led by T-shaped individuals typically feature more realistic timelines, clearer communication throughout development, and higher adoption rates. Their ability to anticipate cross-functional challenges before they become roadblocks prevents the cascade of misunderstandings that derail many data initiatives. Most importantly, they ensure that technical solutions truly address business problems rather than solving interesting but ultimately irrelevant technical puzzles. T-shaped professionals have revolutionized how organizations implement AI, but this raises a crucial question. How do we actually measure data literacy in meaningful ways? While most organizations claim to value these skills, they often rely on superficial assessments that fail to capture what truly matters in real-world scenarios. The fundamental problem with traditional data literacy evaluations is their focus on theoretical knowledge rather than practical application. Ask yourself, would you rather work with someone who can perfectly recite the definition of regression analysis or someone who knows when regression is inappropriate for your specific business problem? The checkbox approach. Can you use SQL? Check. Familiar with Python? Check. Creates an illusion of literacy while missing the critical thinking abilities that define truly data literate professionals. What we need instead is a framework that evaluates how individuals apply their knowledge when facing the messy, ambiguous data challenges that characterize actual business environments. This means moving beyond multiple choice questions about technical concepts to scenario-based assessments that mirror workplace realities. Consider how differently two candidates might approach a scenario where they're asked to evaluate a recommendation from an AI system. One might immediately accept the output based on the system's technical specifications, while another might question whether the underlying data reflects current market conditions or contains hidden biases. Traditional assessments would likely fail to distinguish between these fundamentally different approaches. Scenario-based assessments reveal deeper understanding by requiring individuals to navigate complex situations with incomplete information. For example, presenting candidates with a flawed data set and asking them to identify potential issues before analysis begins tests their ability to spot problematic patterns that could compromise results. Unlike knowledge tests that verify memorization, these scenarios evaluate judgment and critical thinking. Practical challenges offer another powerful assessment mechanism. Rather than asking abstract questions about bias or data quality, present candidates with real examples where subtle issues might impact business outcomes. A retail company might provide historical sales data with seasonal anomalies and ask candidates to develop recommendations that account for these patterns. The exercise reveals not just technical proficiency, but the critical ability to contextualize findings within business realities. Communication skills assessment deserves special attention, as it often separates successful data professionals from those who struggle to create organizational impact. Translation exercises where candidates must explain complex concepts to different audiences provide valuable insights into this capability. Ask them to describe the same machine learning model to a technical peer, a marketing executive, and a customer service representative. Their ability to adapt language, examples, and level of detail for each audience reveals their capacity to bridge the technical business divide. Organizational assessments differ fundamentally from individual evaluations in their scope and approach. While individual assessments focus on personal capabilities, organizational evaluations must examine team dynamics, cross-functional collaboration, and how data literacy impacts project outcomes. They should measure whether teams consistently ask appropriate questions about data sources, whether cross-departmental communications about data occur without translation failures, and whether decision makers can effectively interrogate AI recommendations. The most effective assessment frameworks are themselves iterative processes rather than one-time measurements. Context matters tremendously. As one practitioner notes, understanding the specific needs and maturity levels of stakeholders can influence how data literacy is evaluated and taught. This means regularly adjusting evaluation criteria based on organizational feedback and evolving business requirements. Implementing this practical assessment approach requires commitment, but yields invaluable insights. Organizations that adopt comprehensive evaluation frameworks discover not just where literacy gaps exist, but precisely how these gaps impact business outcomes. This targeted understanding enables them to develop training initiatives that address specific weaknesses rather than providing generic data education that may miss critical needs. While organizations scramble to implement the latest AI technologies, many overlook the single factor that determines success more reliably than technical sophistication. The surprising truth revealed in comparative case studies is that companies with moderate technology but high data literacy consistently outperform those with advanced AI systems but poor organizational understanding. This counterintuitive reality challenges the conventional wisdom that cutting-edge algorithms and massive computational resources guarantee successful AI implementation. Research increasingly points to a different narrative altogether, one where the knowledge and skills of the humans using AI systems matter more than the systems themselves. Consider what happens when two organizations with identical technical capabilities attempt similar AI projects. Despite having access to the same technologies, their outcomes often diverge dramatically based on their organizational literacy levels. The more data literate organization typically experiences smoother implementation, higher adoption rates, and more meaningful business impact. Not because their technology is superior, but because their people understand how to leverage it effectively. Data literacy acts as an accelerator along the adoption curve, allowing organizations to move more quickly from early experimentation to mature implementation. When stakeholders understand AI's capabilities and limitations, they avoid the common pitfalls that derail many initiatives: unrealistic expectations, misaligned use cases, and resistance stemming from misunderstanding. The power of literacy becomes especially evident when examining cross-departmental AI initiatives. In organizations with low literacy, these projects often face significant resistance as teams struggle to understand how unfamiliar technologies will affect their workflows. By contrast, literacy-rich environments see departments actively participating in implementation, contributing valuable domain expertise that improves the final solution rather than resisting change. Perhaps most critically, literacy enables organizations to establish appropriate expectations regarding what AI can and cannot do. Without this understanding, teams frequently overestimate AI capabilities, leading to disappointment and abandonment when systems fail to deliver impossible outcomes. Data-literate organizations approach implementation with realistic timelines and outcomes in mind, recognizing that AI represents powerful but bounded tools rather than magical solutions. The sandbox approach represents a particularly effective method for building this practical understanding. By creating low-risk environments where stakeholders can experiment with AI tools, organizations foster both technical familiarity and the confidence needed to integrate these tools into everyday workflows. This experiential learning proves far more effective than abstract explanations in building true literacy. In a striking example, a healthcare organization implemented two AI diagnostic support systems with similar technical specifications, but approached them differently from a literacy perspective. For the first system, they focused exclusively on technical training for the medical staff. For the second, they invested in broader understanding of how the AI made recommendations and what factors influence its confidence levels. The second implementation saw dramatically higher adoption rates and more appropriate utilization, ultimately leading to better patient outcomes despite using technically similar systems. This pattern repeats across industries and applications. The determining factor in AI success isn't technical sophistication, but organizational understanding. As one data literacy expert explains, the relationship between organizational literacy levels and AI adoption success is evident in comparative case studies where organizations with similar technical capabilities but differing literacy levels experienced varying degrees of success in their AI implementations. High data literacy doesn't just facilitate smoother technical integration, it fundamentally transforms how teams communicate about AI projects. When stakeholders share a common language and understanding, requirements become clearer, expectations align with reality, and implementation proceeds with fewer misunderstandings or delays. The paradox of our AI-driven future isn't whether machines will replace humans, it's whether humans who understand AI will replace those who don't. While organizations scramble to implement technical solutions, individuals face a starker reality. Your relationship with AI might determine your professional ceiling more definitively than any other factor in today's workplace. The silent sorting has already begun. Across industries, professionals are being categorized into two groups: those who can effectively work alongside AI systems and those who cannot. This division creates a widening opportunity gap that reshapes career trajectories more dramatically than technical skills alone. The most vulnerable professionals aren't necessarily those whose tasks can be automated, but those who lack the literacy to leverage AI as a complement to their expertise. AI is fundamentally transforming professional roles by handling routine tasks, allowing professionals to focus on more strategic and creative aspects of their work. In marketing, AI now generates initial content drafts and analyzes campaign performance, shifting human focus towards strategy and creative direction. In healthcare, diagnostic support systems handle pattern recognition in medical imaging, freeing clinicians to concentrate on patient relationships and complex cases requiring human judgment. This transformation requires professionals to develop a deeper understanding of data and AI capabilities. Data analysts, product managers, and marketing professionals increasingly need to interpret AI outputs and make data-driven decisions, skills that depend on solid data literacy rather than coding proficiency. A marketing manager who understands how sentiment analysis algorithms work can better interpret customer feedback data than one who views the technology as a mysterious black box. The professionals thriving in this environment aren't necessarily technical specialists. Instead, they're individuals who understand enough about AI systems to identify where human judgment adds the most value. They recognize that emotional intelligence, ethical decision-making, and complex problem-solving remain uniquely human domains where AI serves as a tool rather than a replacement. Consider two financial analysts with identical technical backgrounds. The first treats AI recommendations as infallible and struggles when algorithms produce unexpected results. The second understands the underlying data patterns, recognizes when context might invalidate predictions, and uses AI insights as one input among many for decision-making. When market conditions shift dramatically, the second analyst adapts while the first becomes increasingly ineffective. Data literacy provides a form of professional insurance because it transfers across industries and roles. A product manager who understands how to evaluate AI outputs can transition between healthcare, financial services, or retail sectors with relative ease. The fundamental skills of critical assessment, contextual awareness, and effective communication about data remain valuable regardless of industry-specific knowledge. Career paths that particularly value these literacy skills are expanding rapidly. Beyond traditional data roles, positions in product management, strategy, operations, and customer experience now regularly require the ability to work with AI systems effectively. These roles demand professionals who can bridge technical and domain expertise, not necessarily building AI systems themselves, but effectively directing their implementation and interpreting their outputs. Organizations increasingly recognize that investing in employees' data literacy leads to better project outcomes and a more innovative workplace culture. Teams with strong data literacy identify opportunities for AI implementation that more technically focused groups might miss. They ask better questions about the business problems AI could solve, rather than simply seeking problems for existing solutions. The competitive advantage for professionals lies not in avoiding AI, but in mastering how to work alongside it. This means understanding AI's strengths and limitations well enough to direct its application toward meaningful goals. It means recognizing that human judgment remains essential for evaluating AI recommendations in context. Most importantly, it means continuously developing your ability to ask the right questions of data and AI systems. While we've explored the theory behind AI literacy, the real question is, does it actually transform organizations in practice? The evidence is compelling. Organizations that have successfully implemented AI literacy programs aren't just enjoying theoretical benefits, they're seeing measurable bottom line results that separate them from competitors still struggling with implementation. Consider what happened when a forward-thinking healthcare organization faced persistent diagnostic challenges. Rather than simply purchasing more advanced AI systems, they implemented a comprehensive data literacy program focused on helping medical staff understand and effectively utilize the data they already had access to. This fundamentally different approach yielded remarkable results, a 20% increase in diagnostic accuracy and a 15% reduction in patient readmission rates. What made this transformation possible wasn't better algorithms, but better human understanding of how to interpret and act on the insights their existing systems provided. The financial sector presents another striking example. When a financial services firm discovered concerning patterns in their loan approval process, they could have simply adjusted their algorithms. Instead, they recognized the deeper issue. Employees lacked the skills to recognize and address data quality issues and algorithmic bias. By implementing literacy initiatives that educated staff on these critical concepts, they achieved a 30% reduction in biased outcomes in loan approvals. This transformation didn't require new technology. It required new understanding. Manufacturing offers perhaps the most compelling case for widespread AI literacy. A manufacturing company facing competitive pressure decided to focus not on advanced robotics, but on fostering data analytics knowledge throughout their workforce. By democratizing understanding rather than centralizing technology, they achieved a 25% reduction in operational costs. Workers across departments could now identify inefficiencies, recognize patterns in production data, and contribute meaningful insights that sophisticated systems alone couldn't provide. Even in retail, where technology adoption often takes center stage, the literacy approach has proven transformative. A retail organization that aligned its AI strategy with business objectives through comprehensive education programs saw their inventory turnover rates improve by 40%. Employees who understood both the business context and the capabilities of their data systems made better decisions about purchasing, placement, and promotion, decisions that directly impacted the bottom line. What's particularly interesting about these success stories is the pattern they reveal. The organizations achieving measurable results aren't necessarily those with the largest technology budgets or the most sophisticated AI systems. They're the ones that have prioritized human understanding alongside technological implementation. Common elements across these transformations include an emphasis on stakeholder engagement from the earliest stages, carefully tailored training programs that connect directly to daily work, and the integration of data literacy into organizational culture rather than treating it as a one-time initiative. Companies implementing this approach have reported not just improved metrics, but also higher employee satisfaction and retention rates. People want to work where their understanding is valued as much as their technical skills. The evidence increasingly suggests that hands-on practical applications yield significantly better results than theoretical approaches. Organizations that implemented experiential training reported a 50% increase in employee engagement scores compared to those relying on traditional lecture-based instruction. When people can immediately apply what they're learning to their actual work, the knowledge sticks and transforms into action. Perhaps most telling is how these literacy-focused organizations handle errors. Rather than treating data-related mistakes as technical failures, they view them as learning opportunities. This cultural shift has led to measurable improvements. One organization reported a 35% reduction in data-related errors after implementing a literacy program that emphasized understanding over mere compliance. That cultural shift toward learning didn't happen by accident. It started with a deliberate first step. While most organizations believe AI literacy requires massive investment and restructuring, the reality is surprisingly different. Transformation begins not with technology purchases, but with a simple 30-day plan that meets stakeholders exactly where they are today. The journey toward organizational AI literacy may seem overwhelming, especially when you're unsure where to begin. Many leaders hesitate, waiting for the perfect moment or comprehensive strategy before taking action. This hesitation creates a widening gap as competitors who embrace even small literacy initiatives gain compounding advantages. The good news? You don't need to overhaul your entire organization overnight. Let's break down a practical 30-day roadmap that can initiate meaningful change without disrupting your operations. In the first week, focus on 3 foundational elements. Assess your current literacy landscape, identify key stakeholders, and establish clear goals. Begin by evaluating what knowledge already exists within your teams. You might be surprised to discover pockets of expertise in unexpected places. Map out which departments interact with data and AI systems, even peripherally, and determine their current understanding levels. Next, identify influential stakeholders across different organizational levels. Look beyond obvious technical roles to include business leaders, mid-level managers, and frontline staff who might become literacy champions. The most effective programs gain traction when they have advocates distributed throughout the organization. Finally, define specific measurable goals for your literacy initiative. Rather than vague aspirations like improved data understanding, target concrete outcomes such as enable marketing team to effectively evaluate AI-generated campaign recommendations. The second week shifts toward resource gathering and pilot program design. Begin collecting educational materials that align with your identified goals, but be selective. Rather than generic data science courses, prioritize resources that directly address your organization's specific challenges and use cases. Design a small-scale pilot program that can demonstrate value quickly. This approach allows you to test your approach with a limited audience before broader implementation, creating quick wins that build momentum for larger initiatives. During week 3, conduct your initial training sessions with the pilot group. Keep these sessions focused on practical applications rather than theoretical concepts. The key during this phase is collecting detailed feedback. What resonated with participants? Where did they struggle? Did the content address their actual day-to-day challenges? This real-time input is invaluable for refining your approach before scaling. Remember that the goal isn't perfect execution, but gathering insights that will strengthen your program. The fourth week is dedicated to refinement and expansion planning. Use the feedback collected to adjust your approach, modifying content, delivery methods, or pacing as needed. Now you can confidently develop a roadmap for expanding your program across the organization. Consider how different departments might require customized approaches while maintaining consistency in core concepts. This iterative process ensures your literacy initiative remains relevant and effective as it grows. This 30-day approach works because it starts where your organization is today rather than imposing an idealized framework. By leveraging existing knowledge and interests in AI, you can initiate productive conversations about literacy that resonate with stakeholders' immediate needs. The structured progression builds foundation, gathers resources, tests assumptions, and creates a sustainable path forward, all within a single month. Even the most technically perfect data literacy initiative is only as good as your ability to advocate for it. This is where many well-designed programs hit their first major roadblock. Persuading those who control resources to invest in something they don't yet understand is missing. You've meticulously crafted your 30-day implementation plan, but now comes a challenge that often determines success or failure: convincing decision makers to allocate time, attention, and budget to this initiative. The dilemma is inherently paradoxical. You're trying to solve a literacy gap by first convincing people who may not recognize that gap exists. Traditional ROI arguments typically fall flat when advocating for literacy programs. Statements like, "This will improve decision making by X%," or "We'll see Y return within Z months," often lack credibility because the benefits of literacy are distributed across multiple business functions rather than concentrated in a single, easily measured outcome. When leadership asks for hard numbers on literacy's return, you're often forced into speculation that undermines your case. Instead of these conventional approaches, successful literacy advocates have discovered more effective framing strategies that connect directly to existing business priorities. The key insight is straightforward but powerful. Don't start with your solution. Start with their problems. One particularly effective approach is framing data literacy through the lens of risk mitigation. Consider how much more compelling it is to show leadership how improved understanding can prevent costly mistakes than to make abstract promises about future benefits. When you demonstrate specific examples of how poor data interpretation led to misallocated resources or missed opportunities, you're speaking a language that resonates with business leaders' existing concerns. For strategic decision makers, competitive advantage framing often proves more persuasive than technical arguments. Rather than discussing the mechanics of your literacy program, show them research illustrating how companies with strong data literacy outperform their competitors. This shifts the conversation from, "Should we invest in this nice-to-have initiative?" to, "Can we afford to fall behind our competitors who are already building these capabilities?" When initial conversations generate resistance, small pilot successes become invaluable advocacy tools. Rather than continuing abstract debates, implement a low-cost, targeted literacy initiative with a receptive department. Document specific improvements in workflow, decision quality, or project outcomes. These concrete examples provide the social proof that skeptical stakeholders often require before committing to larger investments. Addressing common objections requires understanding their underlying concerns. When leaders question whether staff have time for literacy training, reframe the discussion around opportunity cost. What's the cost of continuing to make decisions without properly understanding the data? When they suggest hiring more technical specialists instead, demonstrate how that approach creates bottlenecks rather than organizational capability. When explaining AI limitations to stakeholders, visual tools and co-creation techniques prove far more effective than technical explanations. Rather than describing statistical concepts abstractly, create visual representations showing how models respond to different inputs. Better yet, involve stakeholders in developing these visualizations, transforming passive listeners into active participants in their own learning journey. The most successful advocates recognize that persuasion isn't about overwhelming stakeholders with technical information, but meeting them where they are. By aligning your literacy initiative with what leadership already cares about, whether that's reducing risk, outperforming competitors, or addressing specific operational challenges, you transform the conversation from selling a new initiative to supporting existing priorities. Aligning with leadership priorities gets literacy programs started, but something remarkable happens in organizations that sustain this commitment. Initial investments in data literacy don't just deliver one-time results. They trigger a self-reinforcing cycle that dramatically amplifies AI success rates. Unlike technology-first approaches that often plateau, literacy-first strategies initiate a virtuous cycle where each success propels the organization forward with increasing momentum. This virtuous cycle begins when organizations invest in foundational data literacy. The effects are immediately visible in how projects take shape from the very beginning. When stakeholders understand data fundamentals, they articulate their needs with precision and context, rather than vague requests like, "We need an AI to predict customer churn." Literacy-equipped teams specify exactly what aspects of churn matter most to the business, what data is available, and what constraints exist. This clarity transforms the requirement gathering process. Technical teams receive focused, actionable specifications instead of ambiguous directives. A manufacturing team with strong data literacy, for instance, won't just request predictive maintenance capabilities. They'll specify which equipment failure modes are most costly, what operational data is currently collected, and how predictions need to integrate with existing maintenance workflows. These well-defined requirements dramatically increase the likelihood of successful implementation. Projects stay on track because expectations are properly calibrated from the start. The technical team builds solutions that directly address business needs rather than impressive but ultimately unusable technical showcases. This alignment creates tangible business value that stakeholders can recognize and measure. When organizations experience these successful implementations, something transformative happens. Trust develops between technical and business teams. This trust is the catalyst that accelerates the virtuous cycle. Business stakeholders who see real value from their AI initiatives become eager to explore additional use cases. Technical teams who feel understood and appreciated invest more deeply in translating complex concepts for their colleagues. A healthcare organization that successfully implemented a patient risk stratification tool found that clinical staff, initially skeptical of AI applications, began proactively suggesting additional use cases where similar approaches might improve patient outcomes. The initial success created momentum that carried forward into new initiatives without the resistance that typically accompanies technology-driven changes. This virtuous cycle stands in stark contrast to the technology-first approach many organizations still pursue. These organizations invest heavily in cutting-edge AI capabilities without establishing the literacy foundation necessary to use them effectively. The result is a landscape of impressive but underutilized tools, sophisticated models that generate insights no one trusts or understands, and technical teams frustrated by lack of adoption. The compounding effects of the virtuous cycle extend beyond individual projects. Organizations that sustain this momentum develop an institutional capacity to identify opportunities where AI can create genuine value. They become more adept at distinguishing between problems that benefit from AI approaches and those better solved through other means. This discernment prevents wasted investment and focuses resources where they'll have the greatest impact. Perhaps most significantly, the virtuous cycle transforms how organizations approach data quality. Rather than viewing data as a technical asset managed in isolation, literacy-rich organizations treat data as a collaborative resource with quality standards defined by its intended use. Teams across departments develop shared understanding about what makes data fit for specific purposes, creating alignment that prevents many quality issues before they arise. The sustainability of this approach comes from its balanced attention to both human and technical factors. While technology-first organizations often find themselves repeatedly resetting their AI strategies as technologies evolve, literacy-first organizations build adaptable capabilities that evolve alongside technological change. Their investments in human understanding compound over time, creating institutional knowledge that transcends specific tools or techniques. As we look ahead, we're witnessing the beginning of a profound shift in the workforce. The growing sophistication of AI technologies will create unprecedented demand for professionals who can critically assess AI outputs and explain their implications to others. This evolution makes data literacy not just a useful skill, but essential for future career success. Many professionals today still operate under misconceptions about AI's capabilities, viewing these systems more as oracles than tools requiring careful human oversight. Remember what experts have noted: data is the new oil, but like oil, it must be refined to be useful. This powerful metaphor reminds us that even the most sophisticated AI requires human understanding to transform raw information into meaningful insights. Will you be among those who bridge the gap between AI potential and organizational reality? The choice is yours.